Alright, ladies and gentlemen, in this video, our main goal is going to be identifying the linear pair postulate and our vertical angles congruency theorem. So we're going to be really focusing on our success criteria right down here at the bottom, in which we really want to identify it and learn how to properly utilize each of the following linear pair postulate and our vertical angles congruency theorem. And then by the close of this video, we will do the actual proof of the vertical angles congruency theorem in a paragraph proof form. This will be one of the first times we've seen a paragraph proof in play. So first and foremost, what is the linear pair postulate? Well, we've already talked about what a linear pair is. A linear pair, remember, by definition, is just two adjacent angles that form a straight line. Two adjacent angles that form a straight line. And so if you have a linear pair, the postulate says that if you have a linear pair, then they are supplementary. And the linear pair postulate is one of my favorite postulates to use because it's a little bit more versatile. It actually can be used in two different ways. You can use it in a proof to state that two angles are a linear pair. So that means that simply that they're a supplementary. So I could go ahead in a proof and say that angle 1 and angle 2 are supplementary by the linear pair postulate. Or if I wanted to incorporate value into these angles, I could use it in a different manner, and I could say that angle 1 and angle 2 equal 180 degrees. So I could use it by stating they're supplementary, or I could use it by stating that they equal 180 degrees if I wanted to introduce value into it. So you can actually utilize it in two ways, so it can be a reason for two different scenarios. The other part of this video is going to be talking about what is the vertical angles congruency theorem. One of the most important theorems we're going to talk about all year because vertical angles are constantly a part of our geometry curriculum. Vertical angles are congruent. That's what the congruence theorem tells us. Now be very careful. The number one mistake that I see students make all the time is that when they see vertical angles, they think the definition of vertical angles is the reason why they are congruent. That is not true. The definition of vertical angles is just simply angles that are created when two lines cross. So that's not what our congruency theorem states. The definition is not what is telling us they are congruent. The congruency theorem is what is telling us that vertical angles are congruent. So you will see me really abbreviate LPP. So you'll see LPP a lot for linear pair postulate, and then you'll see VACT for vertical angles congruency theorem in there. But really what we need to realize is that the abbreviations, the names are fine. We need to know what they represent. And the linear pair postulate represents our supplementary two angles that are adjacent, and then our vertical angles congruency theorem tells us that all vertical angles, like here, 1 and 3 are congruent, and 2 and 4 are congruent. So let's take a look at an example of a proof, and specifically a paragraph proof of the vertical angles congruency theorem, the vertical angles congruency theorem. So this is the first time that we've seen a paragraph proof, and the paragraph proof is basically just a more formal approach to a two-column proof. That's all that it is. We're basically taking what we put in a two-column proof and putting it into more of a formal context. It's a little more scholarly. If you take any other higher level mathematics, you kind of get away from two-column proofs. Everything has to be in a paragraph proof form, just because, again, it's more of a scholarly and formal approach to mathematical proof. So let's think about this here for a sec. In a paragraph proof, of course that we know that we have to start, like any other proof, a given information. So we'll simply start off by saying that angle 5 and angle 7 are vertical angles. So it is given. So it is given that angle 5 and angle 7 are vertical angles. All right, and they are formed by intersecting lines. In this case, they're the angles of 7 and 5 and 6 and the missing one, right? All right, so that is what is given to us. Angles 5 and angle 7 are vertical angles formed by intersecting lines. As you can kind of see in that first sentence, it's a little bit more scholarly than it has been in the past for our two-column proofs. So let's kind of think about where we're trying to take this. If 7 and 6 right here, what are 7 and 6 form? Well, think about what the beginning of this video was all about. The beginning of this video stated that two adjacent angles that form a straight line are a linear pair. So 7 and 6 form a linear pair. But take a look over here as well too. 6 and 5 also form a linear pair. So that means 7 and 6 are supplementary. That means 6 and 5 are also supplementary. Does that sound familiar at all by any chance? I hope so, because remember we talked about in previous video that the only way that this makes sense for 7 and 6 to be supplementary and 6 and 5 to be supplementary, 6 didn't change in the same scenarios, in these different scenarios. And only changed it was 7 and 5. Well, the only way that this works is if 7 and 5 are in fact the same angles. So we're going to use that to our advantage. So we see that in the diagram, it shows that 5 and 6 are a linear pair and that 6 and 7 are a linear pair. And this is what our linear pair postulate tells us. The linear pair postulate says that they are supplementary, or I can use them as an angle measure, saying that 5 and 6 add to 180 and 6 and 7 add to 180. You kind of have your choice. It depends on what situation you want to go with next. Because we have already proven the congruent supplements theorem, let's try to use that to our advantage. Because if the linear pair postulate says that 7 and 6 and 5 and 6 are supplementary to one another, that means the only way this works is if 5 and 7 are congruent by our congruent supplements theorem. So our congruent supplements theorem tells us now that 5 is congruent to 7. So a little bit more of a different approach using our paragraph, but overall, in the end, it's the same concept. We're taking what we did with our two column notes and we're putting them into a formal paragraph form.